Hi all, I am Ratnakaram Raju from the competitive.in, the only one platform at any time to enhance your skills. In this video, we are going to discuss about gravity and circular motion. Can go to next slide. Circular motion. When object undergoes circular motion, it must experience centripetal force. Let us take example. For example, a cycle revolving around the circle, it must be in the handle and the whole the body of the circle must be supposed to oppose a forces called centrifugal force. The centrifugal force produces an acceleration towards the center of the circle so that the handle always makes to be turned towards and around the circle. Then go to next slide. Here, as I said, the example here is given. Let us take the angular speed b as the speed of the cycle and the centripetal force which is acting towards the center of the circle. So let red be the circle which is revolving around the cycle which is revolving around the circle. The angular speed of the circle or the cycle is given here, and the centripetal force of the cycle which is acting at the center of the circle is given by a down arrow. Then go to another slide. Here the angular speed of in varied direction, but the centripetal force acting toward the center of the circle is same. Then go to another slide. It is one of the point where the centripetal force acting on the center of the circle is at one point where the angular speed is another point. Then go to another slide. It is also one of the point in the circle where the centripetal force acting at the center of the circle and the angular speed acting on another point. Angular speed. What is meant by angular speed means angular speed can be measured in meter per second or radians per second or revolutions per second. The symbol for angular speed in radians per second is omega or omega. Let's go down the slide. How to how would we need to convert speed into angular speed? To convert velocity into angular velocity or angular speed, omega equal to small v by r, where v is the velocity and r is the radius of the circle. To convert the revolution per second to omega, multiply it by 2 pi. Then go to on the slide. Acceleration. The acceleration toward the center of the circle is given by a equal to v square by r small r, or we have another formula acceleration equal to omega square r, where v is the velocity and r is the radius of the circle, and here omega is the angular speed or velocity. Then go to another slide. Centripetal force equation. As the Newton's second law also said that F equal to ma, where a is the acceleration which is a rate of change of velocity, m is the mass, and force is the F is the force. The general force equation is given by Newton in second law is given by F equal to ma. So the centripetal force equation is F equal to mv square by r, where m is the mass, v is the velocity, and r is the radius. Or we have another formula F equal to m omega square into r. Sorry. All these equations must be learned or noted in your book itself. Then go to another slide. Example for the above topics. And gravity provides the accelerating force to keep objects in contact with the humpback bridge. What is the minimum radius of a bridge that a wheel will stay in contact with the road at 10 meter per second? So we need to solve this problem. Here we need to know what is the minimum radius. Here given properties are velocity is given 10 meter per second, and the gravitational force where small g is given as 10. In some situations and in some problems we may take it at 9.81, and we need to find r, where we have a formula for the acceleration a equal to v square by r equal to g. So r equal to v square by g, where we given v and g. Let us find r. R equal to 10 square by 10. 10 square is equal to 100. 100 by 10 equal to 10. Then the minimum radius of a bridge that a wheel will stay in contact with the road and the velocity of 10 meter per second is 10 meters. Here the problem is solved. Then go to another slide. Newton gravitation. equation. Newton gravitation equation is F equal to minus G m1 m2 by r square. The equation must be learned one more time. Negative sign is a vector sign. G is universal gravitational constant here. M1, M2 are the masses. Then go to another slide. As a negative sign is a vector where it is has the both magnitude and direction. So then go to next slide. More about the equation are M1, M2 are two gravitating masses. R is the distance between their center of gravity. The equation is an example of inverse square law. Then go to another slide. Field strength graph notes. Outside the planet field strength follow an inverse square law. Inside the planet field strength fades linear to zero at the center of gravity. Field strength is always positive. So outside the planet we have some field strength. So it follows an inverse square law which is a Newton gravitational law where F equal to minus G m1 m2 by r square. Go to another slide. Graph of a potential against distance, whereas the distance d is taken along the x-axis and the potential is taken along x-axis, y-axis. As you seen here, minus 1 to minus 0.2, the graph sincerely increasing up to then. The dotted are series 1, the straight lines are given by power series 1. Then go down the slide. Potential graph notes. Potential is always negative. Potential has zero value at infinity. Compared to field strength graph, potential graph is less steep as is shown in the previous slide. Then go to another slide. Orbits. Circular orbits follow the simple rules of gravitation and circular motion. We can put the equation equal to each other, as we have F equal to mv square by r equal to minus g m1 m2 by r square. So we can calculate v here, where v square is given by minus g m1 by small r, where g is the universal gravitational constant, m1 is the mass and r is the radius. Can go to another slide. More orbital mechanics. Time period t is the time for complete orbit a year. It is given by the formula capital T equal to 2 pi by omega, where omega is the angular speed or velocity and should be calculated in seconds. Then go to another slide. Here is the example for the above topic. The moon orbits the earth once every 28 days approximately. What is the approximate radius of its orbit, where universal gravitational constant is given by 6.67 into 10 to the power of minus 11 newtons meter square kg square. Mass of earth m equal to 6 into 10 to the power of 24 kgs, where we have formula for the angular speed which is given by 2 pi by capital T, where is T is the time period, 2 pi by 28 into 24 into 60 into 60. Then we get the angular speed or velocity as 2.6 into 10 to the power of minus 6 radian per second. We have another formula for F, where F equal to m omega square r, where omega is the angular speed or velocity, and minus g capital M small m by r square. So r cube equal to minus gm by omega square. Let it be calculated in your notes or any paper. We will get clarity there. Then go to next slide. Example continued in the previous one, where r cube equal to 6.67 into 10 to the power of minus 11. Then it will come 5.92 into the 10 to the power of 25. The cube root for the 5.92 into the 10 to the power of 25 is 3.90 into 10 to the power of 8 meters. So the radius here is 3.90 into 10 to the power of 8 meters. Then go to another slide. Here is the end. With these equations we can reach the stars. Why I represent this statement here means, for the JEE Mains Physics in the year 2016 to 2018, while you look up the paper, some of the problems related to the gravitational force and Newton laws, the main and important topics are being, as I described or discussed here, are asked. So I referred some of the papers and prepared these slides. If you have any doubts, let me know in the chat box. I will try to clarify it. Thank you.